I'm Deborah Tater, professor of computer science at Virginia Tech and fellow of the Institute for Creativity, Art, and Technology, and I'd like to tell you a story. I was recently in a 7th grade social studies class in a school that was designated as failing. I was just observing. The teacher had set up stations and kids were moving from station to station conducting learning activities. One at a time, students worked with a puzzle of the United States. It was wooden, and each piece was a state. I noticed something unexpected with the very first student. He always put the states back down exactly where he had picked them up, even with distinctive states like Florida and Texas. No sorting, no categorizing, no evidence of visual reasoning. He was working with apparent focus, but he was not problem solving. And virtually all the students in this class did the same thing. They were just stuck. Somehow these kids had gotten to 7th grade without learning systematic problem solving, even for doing a puzzle. Computational thinking is a kind of problem solving. Computational thinking is not thinking like a computer. It's thinking like a computer scientist. Since computer scientists have to represent lots of things and solve lots of problems, thinking like a computer scientist is useful, both in the real world and in school learning. Our approach is to teach kids by integrating computational thinking into core classes like mathematics, social studies, language arts, and especially science. In a new NSF-supported project at Virginia Tech and University of Texas at Austin, we are investigating the integrated computational thinking approach by giving middle school kids modifiable animated computer models of chemistry environments. The kids learn by arguing and debating about what will happen when they run or change the models. To implement this approach, we need to fit into an extremely complex system, but our focus is on teachers and students in schools. Our team represents different interests and concerns: chemists, computer scientists, and science educators. Our team has to coordinate on priorities and learning progressions. We have to design curriculum and technology that not only teaches more, but also is usable by all teachers in the classroom, not just computer science teachers, and be compatible with their teaching priorities. We then must be able to produce detectable learning gains. Most of all, kids really have to learn more. Importantly, integrating computational thinking is a social justice issue because it touches all children, not just the ones that take computer science. Our ChemC project investigates how to teach all students to think this way. This integrated approach can transform the future of STEM education and impact the lives and thought processes of the next generation.